Oh. So I just now finished the practice final. Notice how slowly I am talking because as I speak, I am uploading it and it's done. Yay. All right. So now if you go to Canvas and you go to modules, you can see my canvas, right? Did I just freak everything out? You see this very first module is now final exam preparation. I've got information about, just to remind you when the final actually is. Here's the practice final exam. I'm going to upload a video of the solutions. And that'll be up here also. And that'll happen probably over the weekend. Everybody with me? So go there if you want to get the practice final and start looking at it. Yeah, it's going to have stuff from everything. It's going to be crazy. Crazy. Let me think. Was there anything else I want to show you here? No. Okay, that's it. So let me know. You guys have any questions from homework stuff? Oh, that's why it looks different. There we go. You guys doing all right? It's almost over, guys. It's almost over.
Almost.
Yeah, it's crazy. I remember there were some classes where I was like, I don't know if I'm going to pass or fail. I'm just so happy it's almost over. I remember this. This is a very true story. So no, everybody's good? No questions? I had some good questions earlier. Some of the book questions get a little bit poorly written. So you're not really sure what they want. So let me know if you have any questions. Otherwise, if there aren't any questions, I do want to go over, I'll ask a question for you. If I can find it, here we go, yes. And I want to remind you about something. This is a question somebody asked earlier. This problem right here. So this is 410. This is the very first problem. And I said you can go ahead and use Desmos or something and take a screenshot. But if you're dead set on doing this by hand, they tell you to increment it by 0.2. So you would plug in 0, you plug in 0.2, you plug in 0.4, you plug in 0.6, you plug in 0.8. A really good idea is to do number 2 first. Because why is that? Why do I not have to make my table of values go all the way over to where it comes back down? Why don't I have to do that? So if I start to make a table of values, XY table, or in this case, TH, but what the hell? And I start to draw my parabola, why do I only have to go to a certain point? And then I know all the other points after that. What happens at the vertex? Or let me see, what's a good way to, so now I'm having the same trouble the book does. I can't put together an English sentence that you guys can understand. What is special about the vertex visually? So I'm not saying that this is going to look like this, but what is special about the vertex? Like there's a point right here. That means there's also going to be a point where? Pretend like I drew that right, but it's going to be a mirror image point. You guys understand? So if you know ahead of time where the vertex is going to be, you only have to make your table of values go, and again, this is really T and H, right? T is acting like X, H is acting like Y. You only have to go as far as the vertex, because then on the other side, you would just make mirror image points. So if you had a point here and a point there, and you find your vertex, then on the other side, you're just going to have a mirror image point. So you can kind of count over and make a mirror image, count over and make a mirror image. Yay. I have no idea if that's helping you guys out. Or you could just use Desmos, like I said. I was going to let you do, right? Does everybody remember Desmos? Is anybody out there like, is that a villain from Doctor Who, Jeff? No. Dr. Desmos. All right. So that's a question I asked for you. What was the other thing that just came up? Oh, yeah. Well, I'll let you guys hit that and see what you think. Okay. So, all right. No questions. I'm going to go right back in to where we left off if there's no questions. And what I want to do, what we did at the end there was we figured out two things. There are two things in this section 410. There's this bad boy here, right? And can somebody tell me, does it say up here what it does? No. Well, it sort of does. Can somebody tell me what this means if I do this? What is it that I'm finding?
We see you. We see you, not the page or whatever.
Oh, I'm sorry. All right. Thank you. Now remember, you got old man using technology. You got to help him out. So I was like, what's wrong with you people? I can see this. All right. This guy here. What is it that I find when I do this? There's a few different answers I can accept. What does this do? Anybody?
It intercepts.
It finds the x-intercepts. I like it.
Finds the vertex.
No, careful. This does not find the vertex. We do actually use a piece of this to help find the vertex, right? But this does not find the vertex. So what this does, right, like Cameron said, this finds the x-intercepts, which are also, so if I plug this in and I get 2 and 4, then that means that it goes through 2 and 4, right? And I don't know if it opens up or down, but whatever. You guys with me out there? A little bit? No? So this finds the x-intercepts, which are also known as roots, which are also known as the zeros. Can you spell, Jeff? No. Those all mean the same thing. X-intercepts are called the roots, are also called the zeros. You're the real zero. All right, I like it. And then, now this is what Tanya's talking about. We realize that this bad boy right here is right in the middle, and that's exactly where I would expect the vertex to show up. I got a very strange accent there for a second. So if this opened down, my vertex, wherever it is going to be at x equal 3. So it's going to be 3 comma something. Do you guys remember that? That's the negative b over 2a business. That is such a beautiful shortcut to finding the vertex. All right. Can somebody else, let me push this just a little bit. Let me draw another parabola here. Can somebody describe to me what's going on at the vertex? This is a very strange question, I know. Just somebody tell me something, what's happening at that vertex? How else could I say it? I'm just going to leave it there. What's happening there? The graph has reached its, go ahead.
Its highest place.
All right, it's reached its highest place.
Point.
Now tell me this.
The maximum amount of money it's going to make or whatever, however you want to put it.
Whatever the hell this formula is, that's the maximum. So if this is the formula for the number of apples that my trees are going to make, that's the maximum number of apples, right? Or if this is a profit, that's the maximum profit, blah, blah, blah. Now, can somebody tell me, let's get a little bit freaky here. Can somebody tell me, what's the slope back here? Can somebody tell me something about the slope on this side?
Positive.
Positive. I love it.
Yes.
What's happening as you get closer and closer to the vertex? What's happening? It's turning. I like it. Let me draw. I need a bigger picture here, and I got no room on this page. Oh, well, too bad. So as I get closer, it's turning. It's becoming smaller. You guys understand? What happens right at the vertex? It's going to be flat. It's sort of like you go on a roller coaster, and it's going click, 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 and you're like, why the hell did I do this? Then you get to the very top for that just brief moment of, oh, it's beautiful. And then, wah! And then your slope becomes what?
Negative.
Negative. So another way to describe this, and this I could have done without all the slope talk, but I just wanted to get more formal. That's a turning point. That is a point where the slope changes, right? And that's all I want to say about that. It's very interesting because we don't normally talk about slope for things that aren't linear, but things that aren't linear also have slopes. They just are constantly changing, right? It's positive, 0, negative, 0, positive, right? They're just always changing. Okay. I just want to throw that in. Does that have anything to do with anything you're going to have to do? No. Does Jeff care? No. It's just good math knowledge to have, right? All right. So let's come back to stuff we got to worry about directly. So here's that other thing that we were talking about, the negative b over 2a thing. That's the shortcut to find the x piece of the vertex. Remember, when I ask for a vertex, what must your answer look like? Ooh. Huh? Geometrically, what is the vertex? Ooh, I love
X
it.
and Y piece.
Yeah, it's a point. It's a point. So if your answer for what is the vertex is 7, that is wrong. A vertex is a point. Everybody with me? So this is how I find the x piece. And of course, how do I find the y piece? I just plug it in. So that's what we talked about yesterday. So let's see. Let's do that with something here. Yeah, let's do that with this. I don't think we did this yet. This doesn't look familiar. Did we? I don't think so. Can you guys take a quick hot second and find the vertex for this bad boy? That'll give me a second to go grab. I forgot to bring myself some drink. All right, let's see. I don't really need C to do this, but it's a good point just to identify all the parts. So anybody found the X piece? Anybody got this yet, the X part?
1.5.
Yeah, so 1.5, 3 halves, either way. Like these two negatives cancel, right? So don't forget there's a negative sign and then B is negative. So negative, negative makes positive. and then define the y. So that's the x piece of the vertex. And to find the y piece, I just have to plug that bad boy in. Nine minus 18, negative 9. Is it 70? Is it 56?
Yes.
Yeah. So everybody get that? 1.5 comma 56.
I got that, but instead of, I guess, using the calculator to do 12 divided by 8, I just simplified it into 3/2, but still got the
Yeah,
same.
sure. Yeah.
Okay.
That's what I did too. But, 1.5 is the same thing as 3/2. I like it. And the funny thing is, the way I did this in my head is to make that 3/2, because when I square that, I get 9/4 and the 4's cancel. So sometimes fractions make things easier, kids. Believe it or not. Yeah, I just said kids. Real talk, kids. Let me see. Let me mute my mail stuff here. Mute. All right, guys. Find f of 0. That should be quick. Why is that so quick? Because if I make x 0, then the only thing that's left alive is what?
65.
65. I like it. So tell me this, just from what we looked at, some of you guys already know this, is it the highest or lowest point? Is the vertex here the highest or lowest point based on what I see here and here?
It's the lowest.
Yeah, because this is already higher. So it's got to be the highest or lowest point. Now, obviously, you already knew, does it open up or down?
Up.
Up, because this is positive. So that has to be the lowest point, right? If it opens up, it's got a lowest point. So can somebody tell me this? Let me push this a little bit further. Does this have any x-intercepts, any real x-intercepts? So the vertex is at 1.5, 56, and then it opens up. So obviously this bad boy does not have x-intercepts. Does it have a y-intercept? Of course it does. We just figured it out, didn't we? They'll always have a y-intercept, but sometimes if they open on one side, if they start on one side but open the other way, it's not going to have any x-intercepts. Not real x-intercepts. And what makes me really sad is you guys, if you don't take some other math courses, you'll never work with complex numbers. But maybe you have. Maybe some of you guys have worked with imaginary numbers before. And imaginary is the worst choice of word because they are not imaginary. They actually exist. It's just people didn't like them. Anyway, that's all. Okay, let me see. Blah, 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 blah. All right, let me clear all this away. Bam. Oh, let me see. Let's do this. Let's do a quadratic equation example, and then I have something else I want to do with you guys. Let's do this. Actually, let's just jump right into this then. Where are you? Maybe? Yeah, okay. I think this is what this is what I want. Okay, don't watch. You're going to get sick. Let me find this real quick. Oh yeah, that's right. I want to go this way. Perfect. Let me see. Yeah, look at number 53. Do that for me real quick. Don't worry about 49. It doesn't matter. I'm going to change the I'm going to do this in a different order. I'm going to slowly start to catch up to you guys. A is 1, B is -7, C is 10. So +7, give or take, 7 squared minus 4 times A times C, all over twice A. Is everybody with me so far? You guys okay out there? You get 49 minus 40 is 9. That kicks ass. So I get 7 plus 3 over 2, and I get 7 minus 3 over 2. Is everybody okay out there? Are you guys doing this okay on your own? What's going on? So of course, this I get 10 divided by 2 is 5. And this one I get 4 divided by 2 is 2. All right, so let me know if you have any questions on this process. Whenever I get answers like this, nice whole number answers, that means it would have been quicker to just factor the damn thing. So now I want you to factor this and then find the zeros. Ooh, I got a chat. Yeah, yeah. So yeah, what do you guys get here? You need two numbers that multiply to be 10, add to be 7. You already know what the two numbers are, because I hope some of you guys realize the connection here, right? So they're going to be 5 and 2, and they both have to be negative. So they add to be negative, multiply to be positive. And of course, then I could see the zeros. 5 makes that 0. 2 makes that 0, which is the same answers I got over there, right? So again, it's not surprising. What is the what is the quadratic formula's job? Is to find the zeros of the function. That's what it does. So of course, if I have another way, an easier way to find the zeros, why the hell would I do it that way? Good Lord. I like it. But sometimes I have something I cannot factor. Therefore, I have to do it this way. And that's when you get the gross answers, like 7 plus or minus rad 3 divided by 12 or something. Oh my God. I'm never going to get that doing this. Holy shit. Okay. Maybe. All right, so let me clear this. Everybody got what they want from that? Okay, here we go. Pop. So what I want to do now is what's happening on Thursday. There's two things. Anybody?
A quiz?
Yes. And I don't know if anybody noticed. So this Thursday, once again, this Thursday, I have a meeting. There won't be class. So the quiz is going to open up on Thursday morning, and you'll have until Friday afternoon to do it. So what I want to do right now is sort of do some quick review for the quiz on Thursday. And then starting tomorrow and going into Monday, we're going to do review for the final. So we're going to look at the practice final. We're going to go back and go back over some old stuff that we haven't looked at in a long time. Right? It sounds like a good idea. So just throwing the final at you out of nowhere. So this quiz on Thursday starts at 4:03, which was where we were doing the error. Do you guys remember finding the margin of error? Right, the MOE. So I think I'm gonna give you this formula. So the margin of error, and I did explain that the 4 is gonna, not the 4, but the 2. The 2 is gonna change sometimes when you're in statistics, if you're gonna take statistics next. But the 2 is a standard thing that we use. It's kind of like the most commonly used number. So that's why they put it here. That's the 95% goes with a 2. And then does anybody remember what was inside here? I don't know if you guys remember this thing at all.
P hat times Q hat.
Divided by
N.
N.
Yeah.
The divided by N makes all the sense in the world because we already knew the bigger my sample is, the smaller my error is going to be. So that's where we go, okay, math, good job, math. You got that shit right. Good job, math. So that part of the equation makes complete sense. The bigger the sample, the better, which means the error would be less. I have less error if I take a bigger sample. Of course, the sample has to be a good sample, but that's always assumed. So can you guys go ahead and calculate the error? They tell you there's 200 students. They found 22% had what they call significant, more than $1,000 credit card debt. If that's significant, then I was significant through most of my grad school experience. I'm significant. Go ahead and try to identify what you need and throw it in the equation. Figure out what the error is going to be. So let's see. Just to make sure everybody's on the right track, what is p hat in this problem?
0.22.
0.22, kick ass. So what does it make q hat?
0.78.
7.8, because what these two always have to add to be 1, no matter what clothing they're wearing. So they're wearing hats, they still have to add to 1. And of course, I already told you the n is 200. So you got all your pieces parts. Let's see. 1/7. Am I going to do this in my head? I'm going to try. 0.4. 4 divided by 70 is 2 divided by 35. I don't know. What the hell is that? Is it 0.06? I don't know. Or 0.6. I can't figure out what the decimal place goes in my brain. Ah, cool. All right. Ha ha. Did anybody get that answer?
5.8%.
Yeah. So 0.05. Well, I actually get like 9, right?
Oh yeah, if you round it up.
QQ. So that's how much I think that my estimate is off by. That's on the bigger side, right? If somebody was like, yeah, I think about 40% are going to vote for that guy, but I might be off by about 6%. You're like, I don't know about you. That's not the greatest. 4 or 3% is kind of a standard amount to be off by. And even that's kind of a big amount. So look what they're doing here. Somebody cool with number 8? Any questions on number 8? There's Nikisha. All right. So number 9 says pretty much what I was just saying. They say, holy shit, that sucks. That's 6%, guys. I don't want to put that in a journal article. We're going to look like crazy people. So how do we make that become 4% instead? And by the way, I am going to give you, I think I just said this, I'm going to give you this formula. I'm going to give you this formula. Remember, this formula is the one to find how big a sample had to be. I don't know if that looks familiar to you guys at all. So what am I assuming that P hat and Q hat? I'm assuming that they're the same. I really want this to make sense, guys. Stay with me, stay with me. A sample of 200 led to almost 6% error. So if I want the error to go down to 4%, am I going to have to take a larger or a smaller sample to have that happen? If I want my error to go down to 4%.
Larger. You need a
I
larger.
got to take a larger sample to make things better, right? So it kind of makes sense. I expect my N answer to be bigger than 200. I expect that to happen. So this will be 4 times 0.22 times 0.78. What is the error that I want? What do I put on the bottom here?
0.04.
0.04. I love it. It's a percentage, but I can't work with percentage numbers. I have to change them into their real decimal forms. What's that going to be, smart boy? I don't know. I don't know what that's going to be. Shit, I don't know. Oh, let's see. 1, 2 is 100. That's 25. And then there's another 100. I'm not going to do that in my head. I don't want to. Enforce. Yeah. So, yeah, I don't know. I don't know. I gave up on it in my head. I came out with like 700 something, but I don't know. That doesn't sound right. Yeah, 4. That makes more sense. Did anybody else get the answer yet?
429.
Yes. So if I only take 200, I'm going to get an error of almost 6%. But if I take 429 people, at least, I can get my error down to 4% or less. So that's why a lot of times when you see official polls for like the election, they normally are at least 600, 700 people. That's how they get their error down to 4 or 3%, is they take a large enough sample size. I like it. So if you see a commercial and they say 3 out of 4 dentists agree this is a great gum to use, and you're like, well, did you talk to 4 dentists? How big was your sample? I need to know. Yeah, we only talked to those 4 dentists over there, and one of them was like, I don't know. That's no good. No good. I can't trust that. Okay. So here's one takeaway from all this. If you see somebody put some like, oh my God, 38% of these people do this, and they don't say anything about how many people they talk to, how did they pick the people that they talk to. If you don't see any of that, you cannot trust it. You cannot. It might be true, but you can't trust it if you can't see that information. So don't take stuff at face value, my God. They have to show their work. All right, here we go. I'm going to clear all this away. Clear. Let's see. Oh, yeah. And then, of course, well, here, this is a good little review here. Look at this. Well, where'd you go? Where'd you go, review stuff? Here. This is not a bad, I don't know if any of you guys have ever looked at this page. This is in every single chapter. And they kind of tell you the ideas from each section. So this next quiz is going to be 4.3 through 4.8. So we have the margin of error stuff that we just did. We have the, did we do section 4.4? That doesn't sound familiar. I know I threw a couple of things out.
I skipped over that one.
Oh, good. Okay. Yeah, we didn't do inverse variation. Yeah, okay. So no 4.4. 4.5 was function notation, and then remembering about exponential stuff, right? We didn't do 4.6, which is great. I'm going to leave that for a stats class to talk about. And then, of course, we start getting in the more recent stuff, parabolic graphs, quadratic equations, revenue, cost, and profit. That's where this quiz is going to stop, is right at the revenue, cost, profit stuff. Let's see. So let's look at an example of, what is this one all about? Oh, yeah, it's probably inverse stuff. Yeah. Blah, 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 blah. Oh, here we go. Exponential growth. All right, here we go. Perfect. This is something huge that we talked about way early in the semester. Can somebody tell me, what factor would you want to multiply by in order for a quantity to grow by 15%? That sounds so funky, I think. But so if I put some money in, let me give you an actual number. If I put, if I invested $200 into something that's going to have 15% gain after a year, how can I figure out very quickly how much money I'll have at the end of the year? What would I multiply 200 by?
1.15.
Yes, you remember that shit? Do you remember that? We talked about that like way earlier this semester, and then it came back again. I like it. Hey, Mikey. And then, you know, whatever the hell that is. Let me see. Write an exponential growth function that describes an investment that starts at $500 and grows by 15% each year for X years. Do it. So this was for 1 year, right? So I'll put that there for you. Let's see if you guys can put that together. It's exponential model. So obviously, you guys to know to put this much down. Where does the x go?
The exponent.
Yeah, that kind of gives it away right there, right? Because if I do this 1 year, it's just like this. If I do it 2 years, I'm going to do this whole thing twice. Oh, shit, Jeff. I didn't mean to. All right, that's fine, Jeff. Bam. All right, now I need your calculators. Everybody, get your calculators going. What is f of 4? Figure that out for me real quick. Do that in your head, math boy. No, I don't want to. Okay. Does anyone have that?
$874.50, I think.
Yeah. How you guys doing? Everybody got that okay? Or what's up? All right. What does that mean?
In 4 years, you'll have $874.50 in your account.
Big ass. All right. I like it. I like it. Exactly. Not too bad. If you're going to have something that grows by 15%, it's more than likely risky. So this is all theoretical. You guys with me? I mean, if I had something that would definitely earn 15% a year, I'm putting a lot of money in. Holy shit. All right. I'm going to clear this away. That's what I don't like about these kind of problems. It's like if I knew it was going to gain 15% every year for sure, I'm going to put a shitload of money in there. But this is probably risky as all hell. All right, I'm going to clear all this away. Here we go. Oh, here we go. I love this. What about number 17? This is something we haven't done as much, but just to throw this in here real quick. What factor would you want to multiply by for a quantity to decay by 15%? Or it could be like a 15% discount.
0.85.
Yeah, it's the same idea. It's 1 plus something for exponential growth, 1 minus something for exponential decay. So you would multiply by 0.85. So it's going to be the exact same idea. If I have a bunch of bacteria, if I have 800,000 bacteria and I throw in there an antibiotic or, whatever, injections of bleach maybe or something, and I want it to decay by 15%, I'm going to multiply it by 0.85 to the x. Maybe exposure to a lot of light. Maybe put a light bulb up the bacteria's rear end. Okay. And then, of course, they asked the same question. What would, if you put f of 4 in there, it would tell you how many bacteria are left after 4 days, right? If you did that. Okay. Same idea. So exponential growth, exponential decay, they basically work the same way. This very basic model, right? It's the initial amount times 1 plus or minus the rate to the x. All right. I'm going to clear all that away. Here we go. Oh, somebody's still copying down. Oh, wait. Here we go. Pop. Let's see. Oh. Oh yeah. All right. And these kind of problems, you should be able to eat these kind of problems up for breakfast here, right? Well, let's see if you can. Take a minute and figure out not only what the y-intercept is, but what it means. And some of you guys still don't understand when they ask what it means, don't tell me it's where the graph hits the y-axis. No, tell me in terms of the situation, right? So figure out what the y-intercept is and explain what it means. All right, what's the y-intercept roughly? 0, comma what?
Negative 1,000.
Almost, right? Not quite negative 1,000, right?
Yeah, I guess like 950, 900.
Yeah, maybe. Yeah, I would say 975, 980, something. So whatever. So somewhere between 950 and 1,000. It's not quite 1,000, right? So whatever you guys want to put there. So this could be a wide range of things. Now, more importantly, what does it mean? So if we use this number, what does it mean in this case?
That's how much they lose if they sell 0 parts.
Yeah. So X is the number of parts. So if they sell 0 parts, they're actually out. They lose 975. So of course, what's another name for that 975 then, or whatever number you wrote down?
Your overhead, your costs.
Yeah, some kind of overhead, some kind of fixed cost. And this is what per, do they tell me? In a day. All right, so this is per day. Let me see, chat. Yeah, there you go. Some kind of cost. Well, it's something, it's not an initial investment. It's actually per day. So it's going to be some kind of like combination of things, rent and resource costs and whatever, electricity, whatever the hell. So all that gets wrapped up into overhead. Holy shit. There we go, John. And then the x-intercepts looks to be, they look to be nice. What do the x-intercepts look to be? Here, let me help you. Yeah, it looks to be 10, 0, and 90. And of course, what do they each mean?
Break even.
Yeah, so they break even if they sell 10 or 90. I like it. And of course, the thing that's sort of in the background here, this kind of doesn't make a lot of sense. But what's assumed here, if they make and sell 10 or 90, it's this part that makes it come back down. Because once you get past this, sure, you're selling more, but you're also making more. And the cost to make them is sort of like dominating then. It's too much. That's why there's a sweet spot right there. Nice little sweet spot. And I'm sure they're going to ask us, estimate what the vertex is, tell me what it means, right? You guys should be able to eat this kind of problem up. right? Just it's a little more something you can sink your teeth into easier, this kind of problem. Just please, dear God, when I say explain what it means, I never really mean to just tell me the definition of an intercept or something crazy. I mean, in the context of the problem, right? In the real world, what would this mean? Oh, I got to chat. Okay. All right, let me clear all this away. Goodbye. Okay. Oh shit, what happened? Oh shit. Stop it. Okay, there we go. Blah, blah, blah. So there it is, right? The maximum profit is going to be at the vertex. Let's see. Oh yeah, this kind of problem here. I love this kind of problem. Here, let's do this problem, and then I'll kind of officially end class, and we'll see if anybody. And by the way, this problem goes on a little bit, so don't get too excited. So let's see if we can do this one. Read this through, everybody. Read this through. I love this problem because it kind of brings back older stuff that we've done. Now, just to help you out a little bit. I have no idea which way you guys prefer to do this, but it's not a bad idea to write the information they give me in point form, because then it's just find the equation of the line through these points. What is the point that I can write for this first bit of information? Be really careful.
$450, 200, or 2.5.
Right? X comma P. X is my input. P is my output. And so, of course, the next one is easy. It'll be $5.50 is my input number of bagels. $2 is my output price. I love it. Now it just becomes find the equation of the line through those 2 points. So you need to figure out the slope. You need to figure out the y-intercept somehow. If you want to, you can use this bad boy. And when you finish with this, you're not going to put y, you're going to put p, but I mean, that's fine. You can just switch the letters out, no big deal. You guys with me out there? If you can model the information given as points, finding an equation for them, a linear relationship, just becomes this kind of problem. Find the slope, find a point. You could also do the way where we solve for b, right? If you want to, you could do it that way. Doesn't matter. No, Jeff. There we go, buddy. So here's how I decided to do my slope. I don't know which way you guys want to do it. Is anybody doing it this way here? Or is everybody sort of drawing, or is everybody drawing little things until I do it myself? Is that what's happening? It's like, come on, Jeff, do the prop. All right, so if I do this way, y, and I just have to pick a point, y minus 2.5 equals negative 0.005 times x minus 450. This is a little bit gross, but too bad for all of us. Negative 0.005x. You all have a calculator, so not that big of a deal. Can I do this? 2, 1, 2. Is that 2.25? Is that what that is?
Yeah, you got it.
Yay, go Jeff. So let me make this into a P for price instead of a Y. That's easy enough to do. Equals negative 0.005x, and let me add the 2.5 over. So get over the fact that the numbers are gross. Oh shit. That doesn't matter. It doesn't change what we do. The numbers are gross. Who cares? I just do the same thing I always do. So apparently, for every bagel I sell, I'm going to take the price down by half a cent. Do you guys understand that's what that means? Yeah, so I guess we're in England. We have half pennies. No, it's just math doesn't care about our coin system. All right. So somebody keep track of this for me. Let me see if I can remember this. But you guys have all this written down. That's the price. All right, I'm going to clear this so we can go to the next part of this problem. Here we go. Clear. Now, the revenue. So it kind of makes sense. I want this to just purely make sense. The price was, let's see if Jeff remembers. I think it was that. Is that right? That's the price per bagel. And so to get the revenue, if I know how much each bagel costs and I'm going to sell X bagels, wouldn't I just multiply those together to figure out how much total money I'm going to make? That's why this equation makes complete sense. This is a price per bagel, and I'm going to multiply that by the number of bagels I'm going to sell. And again, I'm going to get one of these bad boys. One of these, you can do it, Jeff. Upside down parabolas. Do you guys see that? When I multiply that through, that makes sense. I expect to get some type of kind of contained. I don't expect my revenue to look like this. Because that means I can get infinite revenue. No, sorry. That's not going to happen. So that's the amount of money that we would be bringing in. Down here, just to kind of cut to the chase a little bit, we're going to talk about cost. The fixed cost is $200. That's going to be this. And to produce each bagel costs 75 cents. That's going to be the slope. So there's my cost function. And of course, the next question is going to be about profit, right? And then how do you get profit? Well, that's the money you have left over after you take the money you make minus the money you spend. That's ground shaking. So I got my revenue. Maybe I should do this on the next page. Yeah, this is getting a little bit cloudy. I'm going to do this part of the next thing. But I like this format. You'll see this kind of thing on the practice final too, where I take you, each question kind of builds. I mean, the book does that all the time, which sort of sucks a little bit, because if you get one piece wrong, then everything else is wrong. But thankfully, you have a teacher that grades you partial credit. So you only lose points when you make a mistake. If everything else after that is right, based on that mistake, you won't lose any more points. Is everybody with me? That's why I don't have Scantrons or something. Good Lord, I don't know what those people are doing now. All the teachers, does anyone of your teachers, I guess they just make a freaking multiple choice thing online. Who gives a shit? All right. I can't even think that way. You never want me to make a multiple choice test. Oh my God. There's so many ways to be evil with multiple choice tests, and I would evil the shit out of that test. All right. Maybe I could do this here because I don't want to try to remember all this shit here. So, I mean, the last kind of step before they start analyzing this is the profit would be revenue. Here's the revenue. Now, here's a big thing. Revenue minus cost, and you got to subtract the whole cost. This is such an easy mistake to make. Do you see how that negative is going to have to distribute? Some people don't, but the parentheses, the 200 remains positive, which makes no sense because the $200 is not money you're making. It's money you're paying. So it makes sense that it will become negative. So I get negative 0.005x squared. 4.75 minus 0.75 is 4. That's nice. Minus 200. So there is my profit function. Let me see how much shit I can jam in here. Can you guys take a minute? The most important point on this for me as the business owner, what is the most important point to figure out from this equation?
The vertex.
Yeah, vertex, right? The break-even stuff is kind of good to know, but the single most important point for me is the vertex. Figure out that guy's vertex. I'll wait. Oh, Jeebus. I know what the answer is. At least part of it, anyway. Let me see. You can do it, Jeff. Yeah, that makes sense. I think it's that. Okay, I think I know what it is. What are you guys doing to find this, by the way? What are you guys doing to find the vertex?
Negative b over 2a to find the x part.
Good. So x equals negative b over twice crazy ass negative a. I'm sorry, twice a. The two negatives cancel, thank God. So I don't have to sell negative stuff, negative bagels. And if you throw that in the old calculator, you'll end up with, I believe, 400. And I believe this is 600. Oh, sorry. I think, yes. So what does this mean? What does that X mean that we just figured out from over here? Sure, this is the vertex, but what does that mean physically?
That's how many bagels you have to sell.
Yeah, got to sell 400 bagels in order to maximize my profit, and that profit would be 600 bucks. Is it in hundreds or is it in thousands? I can't remember. I don't think they said anything about. No, okay. So not a big business, but this is per what? This is per day? Is that what this was? Oh gosh, this crazy book. I think this is per day, right? So that's not bad.
I don't know. Golden Bagel is pretty busy. So,
Dude, yeah. I don't know. I haven't been there in a while, but yeah, Golden Bagel. I used to grade papers there all the time. Okay. And then they would probably ask you some more stuff, but who cares? I mean, that's the most important stuff right there. That pretty much catches us up to where we left off. So I think that's enough for today. So let me know if you have any questions. You need to hang out. Otherwise, you are free to leave. Don't forget that practice file is up there if you want to take a look at it early.
I have a question.
Yes.
On 410. So the equation it doesn't have a let me see. Okay, so you know how we do like the X with the two pieces on the inside and then we see what adds and multiplies to be it?
Oh, yes. So what are we looking at?
Question number 4 on, what is this? 410.
Okay.
So I'm guessing that you do the quadratic formula for this one. It's probably easier. But
Yes.
I have a question. Okay, I have a question.
Yes.
So before I realized you could do that, I was doing it the other way. And
trying to factor.
right. So 1 would be 0.
No C.
Huh?
Yeah, there's no C. There's no like last number, right?
Okay, would that be 0 or no? That's what I'm wondering. If you were going to try to do
it. Yeah. C is 0. That's right. And to be really, really honest, does anyone see how you could factor this?
Well, that's why I was going to say that it would be like 1 would be x plus 2, 3.5, and the other x plus 0. But then you'd have to do the first part, right?
No.
Yeah. Okay.
Oh, I see. All right. I sort of see what you're saying. You can actually just take a t out, which I think pretty much matches up with what you just said in a way. See how a t is in both of these?
Yes.
So it's sort of like undistributing a t out.
Oh, okay.
And then 1, 0 would be t equals 0. And then I can set that equal to 0 to figure out the other 0. Or you can use quadratic formula where c is 0 because it's not there. So
okay.
yeah, either way it'll work.
See it. Okay. Makes sense.
Cool.
Thank you.
Welcome. How's everybody else? You guys all right?
Yeah, I'm doing okay.
Cool. All right. All right, guys. I'm going to head out if you have no questions.
Okay. See you tomorrow.
I'll see you guys later.